In this video, I'm going to show you how to use elimination to solve a system of linear equations with decimal coefficients. So we've got several decimal coefficients here in the first equation. We've got 0.3, we've got 0.1, and we've got 0.5. And we don't want to do elimination with these decimal coefficients because the whole point of elimination is to use integer coefficients and not have to deal with any sort of decimals or fractions or anything throughout the computation process. So we want to figure out a way to turn these decimals into integers. In the past, we've worked with fractional coefficients, and we ended up just multiplying each equation by something to cancel out the fraction. And with decimals, it's a pretty similar idea. We just multiply each equation by something to cancel out the decimals. So what should we multiply by here? Well, to cancel out the 0.5, we could multiply by 2, but then that wouldn't cancel out the 0.1 or 0.3. We'd still have like 0.6 and 0.2. We'd still have decimals. So what we really need to multiply by is the number that will shift the decimal place. Remember, when we multiply by 10, that shifts the decimal place. And all of these decimals just have one number behind the decimal place. So if we multiply by 10, that'll shift this to 3, that'll shift this to 1, that'll shift this to 5, and we'll be all good because those are all integers. So let's do that. Let's multiply this top equation by 10, and 10 times 0.3 is just 3x, and then minus 10 times 0.1 is just 1y, so just y, and then 10 times 0.5 is just 5. The bottom doesn't have any decimals, so we'll just keep that equation the same, multiply by 1, so we have x minus 3y equals -1. Okay, great. So now we have integer coefficients everywhere, and this is elimination as usual. So now we just have to figure out what to eliminate. So why don't we try to eliminate the x? If we multiply this bottom by -3, then that -3x can cancel with the top 3x. So we'll multiply the bottom by -3 and times -3, we'll get -3x. -3 times -3 is 9, so plus 9y. That equals -3 times -1, it's just 3. Alright, and then top we'll just keep the same, times 1, have 3x minus y equals 5. Okay, so now we have our 3 and -3, and if we add the equations, those will cancel. -3 plus 3, that's just 0. And then -y plus 9y, that's like 9y minus y, so 9 minus 1 is just 8y. That equals 5 plus 3 is also 8. So dividing by 8 here, we can see that y equals 1. Now it just remains to figure out what x is, and to do that we can substitute y in any of these equations. Let's try to choose the simplest one. How about this one right here? So x minus 3, y is 1, so x minus 3 times 1 equals -1. So x minus 3 equals -1, and then adding 3 to both sides, we get x equals 2. So our solution here is x is 2 and y is 1. Let's do another example. Here's another example, which is a little bit trickier this time because here we've got two numbers behind the decimal in the top equation, in all of the coefficients in the top equation. And in the bottom equation, we also have more decimals, and these ones just have one number behind the decimal. So how do we deal with this? Well, remember that we just want to shift the decimal place over to get integer coefficients. So just looking at the top equation here, each of these has two numbers behind the decimal. So if we shift the decimal place over twice, we can get rid of those decimals in all of these numbers. So to shift over the decimal place twice, we just need to multiply by 100. The number of zeros that we multiply by tells us how many times we shift over. So like when we multiplied it by 10, that just shifted it over once. When we multiply by 100, that shifts it over twice. Okay, so times 100, 0.04 times 100, we just shift over the decimal place twice, and we get 4x, and then 0.12 shifted over twice, plus 12y, and then 0.04 shifted over twice equals 4. Okay, and then in the bottom, we just have one number behind the decimal place in both of these, so we can just multiply by 10, and that'll shift this decimal place over once. We just get 1x, or just x plus 10y equals, shift that over, -6. And now we have integers, and we can perform elimination as usual. So why don't let's multiply this bottom equation by -4. That way this -4x will cancel out with that positive 4x. So multiply that by -4, and we get -4x. 10 times -4 is -40y, and that's equal to -6 times -4, which is just 24. Then in the top equation, we're going to keep that the same. We get 4x plus 12y equals 4. And now we can go ahead and add, because this 4x and this -4x will cancel. So adding, we get, this cancels, 12y minus 40y. That's 12 minus 40 is -28y. And then 4 plus 24 is 28. So dividing by -28, we get y equals -1. Okay, so now it just remains to figure out what x is, and if we know that y equals -1, we can substitute it into one of these equations. Let's choose a simple one. How about that one right there? The coefficients looks pretty simple in that. So we have x plus 10 times y is -1 equals -6. So computing, we have x minus 10 equals -6, and then adding 10 to both sides, we get x equals 4. So our solution is 4 is x, and y is -1. Let's do one last final example. This final example is the trickiest because not only is every single coefficient a decimal, but we also have different numbers behind the decimal place for a lot of the coefficients. So let's worry about this top equation first. In these two decimals, -0.23 and 0.03, we have two numbers behind the decimal place, and in this decimal here, 0.2, we have one number behind the decimal place. So normally if we have one number behind the decimal place, then we multiply by 10, and if we have two numbers behind the decimal place, then we multiply by 100 to shift that decimal over twice. So what should we do here? Should we multiply by 10 or 100? Well, if we multiply by 10, then this decimal will only shift over once, and we'll have 2.3x, and here we'll just have 0.3. So we got to multiply by 100. So multiplying by 100, we shift this over twice, and we've got -23x, and then for the 0.2, when we multiply by 100, that shifts it over twice. You can think about this as like 0.20y. So shifting it over twice, you get to 20y. And then shift those over twice, you get just 3. Okay, now let's worry about the bottom equation. So here we've got 3 numbers behind the decimal place. Here we've also got 3 numbers behind the decimal place. And here we've got 2 numbers behind the decimal place. Should we multiply by 100 or 1,000? Well, it's kind of like before. If we just multiply by 100, this will shift over twice, but this will only shift over twice, and we'll have 0.9 here, and we'll have a 0.1 here. We don't want any decimals. So we'll multiply by 1,000, which just shifts the decimal over 3 times in each of these. So for the 0.001, that becomes shifted over 3 times, and you get 1x, so just x. And then for the 0.01y, you can think about that as 0.010y, and you shift it over 3 times, you get 10, so 10. So x plus 10y equals, and then shift this 0.009 over, 1, 2, 3, that just equals 9. Okay, there we go. We've got integer coefficients, and we can finally begin starting on elimination. So what are we going to eliminate here? I think it'll probably be easiest if we eliminate this 10y and this negative 20y, because we can just get this 10y up to 20y and then it'll cancel. So let's multiply this bottom by 2, and we'll get 2x plus 20y equals 18. And the top equation will keep the same, times 1, get negative 23x minus 20y equals 3. And now if we add the equations, this negative 20y will cancel with this 20y. So let's go ahead and do that. We'll eliminate the y here, and negative 23x plus 2x, well, negative 23 plus 2 is just negative 21x, and then 3 plus 18 makes 21. And if we divide by negative 21 on both sides, we get x equals negative 1. All right, so now it just remains to figure out what y is, and we can use that. We can do that using x equals negative 1. Let's go ahead and substitute that into one of the equations. How about this one right here? That looks like the simplest one. So we've got negative 1 plus 10y equals 9, and we just have to solve this equation. So add 1 to both sides, 10y equals 10, and then divide by 10, and we get y equals 1. So there's our solution. X is negative 1, and y is 1. The main takeaway of all these examples is that to perform elimination with decimal coefficients, you want to multiply by a number which will cancel out the decimals. And the number is always going to be 1 with some amount of zeros after it. So like 10, 100, 1,000, and the number of zeros just tells you how many times you're shifting the decimal place. And you just need to shift the decimal places until all the decimals are gone. This way the coefficients will become integers, and we can proceed with elimination as usual.